Video 3, Newton's second law. What's Newton's second law? Deals with cases where the forces are unbalanced and therefore acceleration will occur. So we contrast that with Newton's first law, where a body is either stationary or constant velocity, therefore all the forces are balanced. Newton's second law is for unbalanced forces and therefore acceleration or deceleration will occur. And sometimes it's said the acceleration of an object varies in direct proportion to the external unbalanced force applied to it and inversely proportional to its mass. That's quite complicated. What does that mean? Quite simply, F equals ma. The force is equal to the mass times acceleration. Unbalanced force in newtons, mass is in kilograms, our standard units, and acceleration is meters per second. So F equals ma. So the force, so if you increase the force and the mass stays constant, the acceleration must increase. Okay, and if you want to cause a large acceleration, you need a large force. There's a couple of scenarios where the mass will change, something like a rocket burning its fuel. If the mass changes and the force remains the same, the acceleration must increase. A little bit of maths. If you're good at understanding your maths, that will make sense, but otherwise don't worry about it too much. Also stated as, so it's given those, but also can say the rate of change of momentum of an object is directly proportional to the unbalanced force acting upon that object. So Newton's second law can be framed in terms of change of momentum and forces. What does that mean? Well, it's on our formula sheet. Here's our force, unbalanced force. There's our change in momentum, delta P, divided by time. So we can also have it as written like this, which is because momentum is mass times velocity, and because we're talking about a change in velocity and a change in momentum, we can say V minus U, and it's over a time period. And all that is equal to ma. So all these equations describe Newton's second law. Some examples. Dropping something. As soon as you drop it, it accelerates due to the unbalanced force of gravity. Yep. So it accelerates at 9.81 meters per second per second. Throwing eggs. What do we mean by that? Well, have you ever tried to catch an egg, or imagine someone catching an egg? If someone threw you an egg, and you can have competitions. There's competitions around the place where people try. You start rows of people throwing eggs between each other. You start fairly close together, and then each time you catch the egg, you've got to take a step backwards, so the gap gets bigger and bigger. And you see that the people that win or go the furthest in these competitions, when they catch the egg, they catch it, and on first contact, they keep their hands moving with the egg, and so the egg is slowing down over a long period of time. Therefore, the force being applied to it is less. Therefore, the deceleration is less. Therefore, Newton's second law applies and the egg doesn't break. If you just try and catch an egg with your hands still and rigid, what do you think the egg's going to do? It's going to break because the force is too great, causing it because the acceleration is too great. So the change in momentum is too great. The egg breaks. So a lot of these things we do intuitively without knowing our physics, but once you know the physics, it's quite obvious. Driving, where would we be without Newton's second law of driving? We wouldn't be accelerating or decelerating. In fact, anything that undergoes acceleration is Newton's second law. So we can, if you are given scenarios and you're asked to choose what Newton's law is applying, well, we've got the couple of clues there. If there's acceleration or deceleration, it's got to be Newton's second law. If it's stationary or constant velocity, it's got to be Newton's first law. That's how it works. Can be dangerous. So fighter pilots have to go through training, because in the jets they can experience decelerations and accelerations that are far too great for the human body, and it can cause them to black out. And on your OneNote there's going to be a video on pilot training that shows you what happens when they're put through tests in a machine called a centrifuge, which spins them round and simulates the forces that they would experience in a jet fighter. Consider a car. So here's a car, velocity is 0, so Newton's first law applies, all the forces are balanced. Yep. Now it's travelling at a constant velocity. It's still Newton's first law, so all the forces are balanced. We've now got the motor force, but we've also got a friction force, which is coming from the tyres and air resistance. But you can just write it as a single force, as long as you label it correctly. So again, Newton's first law. Now it's accelerating, okay? The motor force is greater than the friction force, and therefore it's an unbalanced force, and therefore it will be Newton's second law. An example. What is the magnitude of the average force applied by a tennis racket to a tennis ball during service if the average acceleration is this? So we're given the acceleration, we're given the mass in grams, so just look out for that. That's got to be in kilograms, and we're after the force. So F equals ma, convert grams to kilograms, got our acceleration, 700 newtons. Okay. A toy car is pulled across a smooth, polished, horizontal surface, so we're slimming down the friction component with a spring balance. What's a spring balance? This is a spring balance. Okay, it's got a spring in it, and it measures force. The reading on the spring balance is 2 newtons, and the acceleration of the toy car is measured, maybe by a motion detector, as 2.5 meters per second. What is the mass of the toy car? Now, so friction can be ignored. The weight force is balanced by the normal force, so those two cancel each other out. So the net force is horizontal, and therefore the net force is what's pulling the spring balance on the car. So F equals ma. So the 2 newtons from the spring balance is what's causing the acceleration, and so we can then work out the mass, and the mass is 0.8 kilograms. Hopefully you understood that. Pause it and read through that again if you're not. Basically what this is saying is that other than the vertical forces, horizontal forces, other than the horizontal forces, all the vertical forces cancel each other out, plus we can ignore air resistance because it's smooth and polished. So you're going to have this in your workbook, question 7, where you just have to practice using those formulas and rearranging them, and that's always good practice for us. And the answers will appear there, and I'll have those available for you. And you also will have to do question 8 in your workbook, working out the retarding force. And a retarding force is a force causing a deceleration or a stopping. And you should also be able to have a sheet called Newton's second law questions, and that will be available for you to do as well. Lucky you. And there'll be a video called Newton's second law, which will just summarize what I've just been saying as well, if you want to have a different voice. So next video we look at Newton's third law. See ya.